Okay, so after defining mesh and loop, let's go to the next thing, and next thing we want to discuss is node, branch, or we can say one more thing is junction. So what do we understand by node, branch and junction? So like loop and mesh, the node and junction is also can be used alternatively, but there is a minor difference between junction and node, and what you have to take care, let's talk about that thing. So what you can say, the first thing is known as node. The first thing is known as node. And what do we understand by node? The idea of node is simple. The contact point of two or more electrical element is known as node. Contact point of two or the contact point of two or more electrical components. The contact point of two or more electrical components is known as node. Okay, let's see how it works. So you can say, suppose we are having this. This is one circuit, let's say. This is one circuit. Then I am interested in knowing how many nodes are available in this. What is the fundamental question? Let's deal with the fundamental. And fundamental is how many nodes are available. So let's apply the definition. The contact point of two or more electrical component. So one component is this and one component is this. The contact point of two electrical component is known as node. So you can call this as node number 1. The contact point of two electrical components, two or more electrical components. So two or more. So here we are, this is contact point of three electrical components. So you can call it node number 2. You can call it node number 2. Because this is also the contact point of what? Contact point of this branch and this branch. Correct? What is next? The contact point of this two is known as node. So this is node number 3. Correct? The contact point of this two component is known as node number 4. And contact point of this two component is known as node number 5. But when you look at this line is, you have to take care of this line. This line is short circuited line. This line is somewhat the same wire is connected. You can call this wire, this is a connection which is, this is common point. What we can call common point. Common point means you can take an example of the water flow. water level. If water level is constant, there will be no flow of the water. So what we are saying, there is no potential difference here. The potential of, if I call this as node number 4, 5 and 6, then I should say the 4, 5 and 6 are same node. Why it is same node? Because there is no component in between. If there is no component in between, there is no rise or no fall of the voltage. If there is no rise and no fall of the voltage, we can say this will have the same voltage. So you can call this whole, we can call this whole as a node, and I am calling this node number 4. I am calling this as a node number 4. So I hope the definition is clear. What we can call node, any contact point of two or more electrical components. Contact point of two or more electrical component is known as node. So number of nodes here, we can say number of nodes is equivalent to what? Number of nodes is equivalent to 4. Now let's go to the next thing. And what is next thing? Next thing is known as junction. Because like mesh and loop, there is one more thing which is known as node or junction. So what do we understand by junction? Junction, what we call as a junction. So junction is contact point of three or more. Contact point of what? Contact point of three or more, not two or more. Two or more is known as node, but contact point of three or more electrical element is known as junction. So can we define the junction? Contact point of contact point of contact point of what? Contact point of three or more electrical components. Contact point of three or more electrical components is known as junction. The contact point of three or more electrical components, the contact point of three or more electrical component is known as junction. The contact point of three or more electrical component is known as junction. So you can say how many junctions are available here. So you can say this is, let me use some other pen here, and what I am saying that when you talk about this, this is the contact point of two electrical components, so this cannot be a junction. It is node but not a junction. But when you look at this point is what? This point is contact point of three electrical components, and contact point of three electrical component is known as junction. So you can say node 2 is a junction. Node 2 is what we can call node 2 is a junction. Let's talk about 3. So 3 is not junction because it only connecting the two branches, so it is not junction. But when you talk about this is the contact point of three branches, and if it is contact point is of three branches, so you can call node 4 as a node 2 and node 4 as a junction. Always remember there is one law for analysis of a network, and that law is known as Kirchhoff's current law, and Kirchhoff's current law is applicable to both. It is applicable to junction as well as node. But node is a more general term. That's why we call it as a nodal analysis. Why it is nodal analysis? Why? Because nodal includes everything. Means if you want to satisfy the Kirchhoff's current law, the Kirchhoff's current law will be satisfied at node number 1, node number 2, node number 3, node number 4, satisfied to the all. But keep one thing in mind. If this is not rule, just one observation. And what is observation? Suppose you want to calculate the quantity, unknown quantity, then apply the Kirchhoff's current law at a junction. Junction will give you the answer for unknown quantity. Node cannot give you. See here, if current coming from this branch is I, so current coming to the branch is I, then what is the next question? How much current will go away from the branch? And that is also I. So we don't care for this. So what I can say? I can say observation. KVL, KCL, Kirchhoff's current law is applicable to both. It is applicable to node as well as it is applicable to the junction. But if you want to calculate the known variable, just apply it on a junction. This is just observation, not a rule. So you can say, what is the first rule? First rule is this. Few observation. KCL is applicable to both. Both means I should not write both, because both means what? Both are having different identity. No, KCL is applicable to all the nodes. But this is for your understanding. KCL is applicable to both, whether it is node and junction. It is applicable to both node and junction. It is applicable to both on node and junction. So this is our first observation, that KCL is applicable to both node and junction. But if you want to calculate, this is again observation. What we can say? For calculating unknown, for calculating the known variable, KCL should be applied to, for calculating the known variable, KCL should be applied to the junction. So I can say that all the doubts related to the nodes, junction, branch, and everything is clear now. So this is not rule. This is just my suggestion to you, that whenever you want to calculate this, you have to apply the KCL at junction. So I hope this is clear. What is the next thing? Next thing we have to define with respect to circuit or a network, that is known as branch. So can I say branch? And how you can define the branch? The path between two nodes is known as branch. You can say path between you can say the path between two nodes is known as branch. Or how many branches are there? So you can say number of branches 1, 2, 3, 1, 2, 3, 4 and 5. How many branches are there? 1, 2, 3, 4. 1, 2, 3, 4 and 5. 5 branches are there. So these 5 branches are known as branches. This is the path between two nodes, branch number 1, path between two, branch number 2. Let me call it B1. Let me call it B1. Let me call it B2. Let me call it B3, branch number 3, because this is the branch path between two nodes. Let me call it B4. And this is known as B5. So how many branches? There are five branches. So you can say number of branches in the circuit is number of branches equal to what? Number of branches equal to 5. And we can call it B. How you define it? Number of branches, I am calling it B. So there is a relationship and very popular relationship between branch node and and independent loop, and that relationship is known as this relationship between relationship between what? Relationship between branch, or I should say number of branches. So I am calling number of branches as B. I am calling it B. And I am calling number of nodes as N, not junction. We are just saying number of nodes. Or I should say number of and we can call number of nodes as N. So we are calling number of branches as B, number of nodes as N, and number of mesh or independent loops equal to, I am calling number of mesh or number of independent loops as M. Number of mesh, or we can call it number of independent loops. We can call it number of independent loop or mesh. I am calling it M. And there is a relationship between all this. You can say M is equivalent to B minus N plus 1. So in exams they will give you one of the variable. M represents mesh and it is not loop, it represents mesh. And what is mesh? Number of, or you can say mesh represents how many equations you require to solve a network. That we will discuss in KCL. But there is one more thing for mesh. Mesh is also known as, mesh is representation of number of equations required to solve a network. Number of equation required to solve a network is known as mesh. So b minus n plus 1, and let's verify this formula. This formula is correct or not correct. What I can say? I can say this. Let's talk about this. When you look at this circuit, how many branches are there? So you can say 1, 2, 3, 4, 5 branches. So in the given network, number of branches are 5. So given example, b equal to 5. B equal to 5. How many nodes are there? So 1, 2, 3 and 4. So you can say nodes is equivalent to 4. Correct? Let's verify the result. When it is asked to calculate the number of mesh, or when they asked to calculate, okay, I should write this here. We can say number of branches in example what I can say, in example we can say that number of branches is equivalent to n equal to 4. And if they ask that how many meshes are available in this, so you can say m is equivalent to b minus n plus 1. And how many meshes are available? So you can say number of mesh is equivalent to 2. B minus S, 5 minus 4, 5 minus 4 is 1, 1 plus 1 is 2. And when you look at the circuit, you can say that how many mesh are there? Only 2 meshes are available here. So this is the relationship between what? This is the relationship which is satisfied by every network, that number of loops, number of independent loops, not we are not talking about just loop, number of independent loop, or we are talking about, to be very specific, we are talking about the meshes, and how many meshes are available in the network, that is given by b minus n plus 1, where b represents the branches, n represents the node, and 1 is a constant. So I hope this formula is clear with respect to the network. With respect to the network, this is very important idea for the network. So we have talked about everything. We have talked about everything across for a network terminologies. Now we will start the analysis of the components, that how resistor will behave. What do you mean by voltage? What do you mean by current? What do you mean by resistance, capacitance, and inductor, and how current flows, and how many voltage, how many sources, energy sources, and what is the characterization of the energy sources, that we will talk about in next lecture.